Hey, welcome back, everybody. We are going to talk a little bit about human population growth. I think that's where we left off. We've been doing a little bit of this in class, so this would be a pretty easy set of notes, and they're very short. Let's start and look at a graph that y'all did in class, where we're looking at kind of distribution of human population and how it changes. And so it's really demographics. It's kind of the study of human population, and it's very important. We gave a few examples in class of why we should be looking at demographics, and I think we saw that if your growth rate is too small, then we run into issues. If your growth rate's too large, then you run into issues. And so it's one of those things we need to kind of look at. And so here we have the graph. Yours should be very similar, the one you constructed using very similar data, where we're seeing this exponential, the exponential part of, or y'all learned it as that J curve, right? And so you see this exponential. We're about in and to show you, when this graph was done in the 1998, they said that in 2013, that was 14 years, they predicted about 7 billion people, and guess what? We are at 7.1 billion people on the planet today. And so it's really easy. If you follow this J curve, it's an exponential, and so we can predict what our population will be in the future. And so so we're a little concerned about the numbers and how we're going to deal with so many people absorbing so many resources. And so your graph should look something like this, the one you turned in. But anyway, demographics or demography is going to be the study of this human population. Very important. We see this exponential. Of course, I just talked about that. We see the exponential or the J curve over the last several hundred years. All right, another way of looking at it is these age structure diagrams. Excuse me, which we should be developing now in class, right? And so we're using our own data, which is kind of fun. But just to go over it one more time, we have a breakdown. These are over on the side. We'll have age groups over here. And so 0 to 4, 5 to 9. This is, I think we ran ours very similar in class. The breakdown here, we're going to do percentages. Here they have probably these are in what's horrible is they didn't label their axis here, did they? And so we don't really know what unit that's in, but we're going to use percent, and I'll show you how we do percent in class when we do that activity. But percent is really good because it shows you that breakdown of male and female. And here we have, it looks like males on this side and females on this side. And so we're able to break down and see at any given time what the makeup of that, the age and gender of that country, the kind of the breakdown. It's a very important thing to look at. And we have developing countries and industrial countries. Industrial, we're seeing more of this zero population growth, which I'll talk about in a second. Developing countries, we're seeing more of this kind of a pyramidal, triangular type shape, more of a positive growth. And we'll talk about that on the next slide here. All right, and so here's, we have a rapid growth and a slow growth. Both these are going to fall under the positive growth, which we talked about. And anytime you see a positive growth, you'll have a bigger base than you have on top. And that just simply means that you have a larger, younger population. And this will be moving up through time as time goes by. And this is, once again, represents percent. And so these are percents. And so when I read these, I should be able, if I asked a question, well, what's the 0 to 14 breakdown? How many are are female? What's the percentage makeup of females in the age range of 0 to 14? And so I could take this right here, and I would know, well, this section is looks to be about 4.5, and this is right around 4, and this is right under 4. So I should be able to add those up. 8. About 12, what do you think, 12.5, something like that. So somewhere around 12% of this entire population is female from in the ages of 0 to 14, about 12%. And so reading those graphs is very important, and we'll practice a little bit on those. Here's another where we see zero growth, where we're seeing kind of just these more of a straight. In other words, each year I'm not adding an increased percentage of that age group, and so I'm pretty much holding steady. We also have a negative, and we talked about that. And negative growth is going to have this kind of shape here, where my base is going to be smaller than the top, and so I have a much smaller number of younger individuals, more older individuals. And we talked about how scary this is, and a lot of countries are dealing with this negative growth type model or age structure, negative growth. And what that means is, we talked about the what can end up happening with that. And that simply means that as this increases in age, as this age group increases in age, you end up with a very small part of the population, which is the working part of your population, doing all the work, running the businesses, running the cities, ends up being a much smaller group compared to the older group up here. And so we have to be careful with those negative growth. Several countries are having to deal with that now, and I think we gave several examples in class. All right, and so next slide, talking a little bit about mobility. And this is important because it's introducing two things. This overall, if I'm looking at the growth of a population, well, what can cause growth? Well, mobility is going to be one of those, and that's simply the ability to move in and out of an area. And if you're moving into an area or moving into a population, we call it immigration. If you're moving out of a population, we call it immigration. So you have immigration and immigration. Moving in and moving out. There's some other things we should add those that can affect the population. Anybody have some ideas? How about birth rate? All right, and so birth rate, how many babies are being born in an area? And so you can get a rate of birth, which is important. And then, of course, with that can affect a population would be the death rate. So how many individuals are dying within that population? So we have death rate. And so birth rate, death rate, immigration are going to be big factors. Let's from that. Of course, we have some examples here. Sorry, I didn't pull up that slide of leaving. Oh, wait. We wanted to come up with an equation before we're done. We want to come up with an equation. And so right up here at the top, I'm going to put population increase. And so population increase. In order to see a population increase, what must happen? And so let's write it as an equation. And so what I'm going to see happening is if I take, what are two things that can cause an increase? And so, well, let's look at first if I have people moving into an area here, immigration. So if I took my immigration, if you'll allow me to just use IM for immigration, if I took that and I added to it my birth rate, right? Because that's going to increase a population. My birth rate, let's put BR, is that all right? So if I take my immigration and my birth rate and I subtract from that, what are the two things that decrease a population? Well, I have immigration, that's leaving, and so we'll use EM here, immigration, plus, here we go, what's going to subtract or remove? That's going to be death rate, all right, or has a tendency to lower, right? And so if I take these two, let's put these in brackets and make it a little more mathematical looking here. And so what happens if I take, these are the things that tend to increase, right? These two things, and these two things decrease. And so what happens if, in order to see a population increase, what's got to happen? Well, this has got to be greater than this. And so I'll get this positive number. If this is less than that, right, if y'all remember from your math, I get a negative. And so a population increase, this has to be this has to be a larger number than this. And this just kind of makes sense, putting it in kind of a little mathematical equation. A population decrease, I would have this larger than this. And so my immigration and my death rate would be larger than my immigration and birth rate added together. And that would cause a population decrease. All right, so however, just a couple of ways of looking at that mathematically. Voila, we have human population. That's really all we're going to talk about. That was a very short, sweet video on age structure. We'll be doing a lot of that in class. And I think we're done with the human population component. Thank y'all for tuning in. See you on the next set of notes. Bye.